Okay, so this is chapter 3.6, and we're going to look at quadratic versus exponential graphs. And the learning goal is here, by the end of this class, I should be able to see the difference between a quadratic and exponential graph. I should also be able to evaluate powers. Now, here are some of the power rules. It's kind of review from grade 9, so let me go through them fairly quickly. If you have this is called the what? The base, right? And this is called the exponent, right? Yeah, or it's the power, right? Usually the whole thing, we call it a power. So multiplying powers, when we multiply powers, what needs to happen? When we multiply powers, what needs to happen? You add what? You add the exponents, right? So it's A, B plus C. Notice though that they do have to have the same what? Same base. Do you remember this from grade 9? Okay, so they do need to have the same base in order for you to simplify this by just what? Adding the exponents. Okay, so example, let's do just a quick example here. 2 times 2, 3 equals to what? What does that give you? 2 to the power what? 5, right? And that 2 to the power 5 is what? 30? 32. Okay. So that's how you simplify powers when you are doing the multiplication. All right, so when we're dividing powers, you need to actually subtract the exponents if you want to simplify it. Remember though, we still need the same base. Okay, so you do need the same base here. So if you have 4 to the power 5 and 4 to the power 3, what does that become? 4 to the power of 2. And 4 to the power of 2 is what? 16. Okay, so that's it. All right, let's go to power rule. So in the case of power rule, you have a to the power of c. Oh, let me put b there. To the power of c. And what happens now? Yeah, you actually have to do the multiplication. And it's kind of interesting that, look here. For multiplication and division, right? To simplify the exponents, what did you have to do? Add and subtract. That's kind of like the next thing in the bedmass order, right? Here, it's what? Exponent of exponent. And what do you do to simplify that? You do the multiplication, which is one lower in the what? In the bedmass order as well. You got it? So that's an interesting thing. Now remember, 2x squared cubed, what would that become? 2 what? 2 cubed, right? And what else? X to the power what? 6. Because, look, everything inside here is being what? Cubed. Okay? So that means that 2 is being cubed and also the x is being cubed. Okay? So that's 8x 6. Okay? Shh. Remember though, yesterday I said, if I have x plus y squared, okay, can I square just both of them? No, right? In this case, you cannot just square both of them. Okay? Because it's not a single term. In this case, it's a single term, and that single term is being multiplied 3 times. However, these guys, okay, is not a single term, okay? So that means you have to do the what first? The brackets first, and then the exponent. You need to follow BEDMAS order. So in this case, you do need to add the 2 and then square it, okay? In this case, notice that there isn't anything to do inside the brackets. Do you understand what I just said? There's nothing to do inside the brackets. So then, therefore, I could do the exponent right now on everything. However, in this case, there is something to do still in the brackets, which is the addition of these 2. But I cannot add those 2, so I cannot, okay, distribute the 2 there like that. That's wrong, right? So what do we do with this? This is wrong. What do we have to do with this, I told you? X plus y and times what? X plus y, right? So let's try FOIL on this and see what you got. X squared plus xy plus xy plus y squared. And that gives you x squared plus 2xy, okay, plus y squared. Notice that, look, there's actually this extra middle term, okay? You do have that, yes, x squared here, and you do have that y squared also, but you also have this middle term, and that middle term is this times 2. Okay, so this middle term is actually this times 2. You understand that? Okay. Yes. If it's power 3, then you have to put another one of these, and you do. Yeah, good question. Let's try that. Shh. Shh. You might need a little bit of more room, but let's try interesting. Shh. Shh. Okay, what if you have x plus 3 and then it's cubed? Then you have to do the bracket how many times? 3 times. Okay, let's try it. Shh. So remember what I said. Shh. When there are 3 things to multiply, what did I say? You multiply 2 of them, and then you multiply the one with the other one you got. Shh. So let's multiply these 2 here first. Okay, are you ready? So I'm gonna multiply these 2 first. I like to always multiply the 2 brackets on this end first. So let me just do this. And this, I know is this one, right? So let's just borrow this. Let's just borrow this one here, because we want to save some time here. So I know that this is going to be x squared plus 2xy plus y squared. Okay? So now guess what you do? You have to multiply the x with everything there and the y with everything there. Go ahead, do it. So x with everything here and then y with everything here. Go ahead. All right, let's listen. Okay, so this is x times x squared, which is x cubed. Okay, this one times this one is plus 2x squared y. And then this one times this one is plus xy squared. Plus y times that is x squared y. Okay, this times this is plus 2xy squared. That times that is plus y cubed. Shh. X cubed. This one, oops. X cubed. Shh. This one and this one. So that gives you what? Plus 3x squared y. This one and this one equals what? Plus 3x y squared. And then the last one is plus y cubed. So a to the power negative b, okay? If you have a negative exponent, remember, like if you have positive exponents, what does that mean? Multiply it a few times, right? Well, if you have a negative exponent, that would be the what? The opposite thing. Well, instead of multiplying multiple times, you're actually going to end up dividing multiple times. So this actually is a division, right? A to the power of b. Do you understand that? You're dividing 1 by a, dividing by a, dividing by a, b times. Huh? Yeah. So remember like this number right here? Shh. Usually what happens here is shh. Okay? Yes. But you can actually break this up into 1 times 2 squared. Right? So it's equals to 1 times 2 times 2. Right? Which is 4. Same thing here is like 1 divided by 2 divided by 2. Which actually equals to 1 over 2 squared. Okay? All right. Now, an example would be something like this. If I give you 2 to the power negative 3, what does that equal to? That equals to what? 1 over 2 cubed, which is 1 over 8. Okay? All right. Negative exponents is division. Okay? Is that okay? Here? Yeah, again, I said, if it's like this, if it's a positive exponent, you multiply this one twice, yes? So you multiply this one twice because it says to do twice. However, you can think of this negative as being the opposite of that. And so instead of multiplying twice, you're doing it what? Dividing it twice. Okay, so you're doing 1 divided by 2 divided by 2. Okay? I don't know what happened. What is that? Okay, anyways. So what is anything to the power of 0? I already talked about it here. It equals actually to what? 1. Okay? Now watch why this is 1. So for example, let's say I have 2 to the power 3. What does that equal to? 8, right? 2 to the power 2 equals to what? 4. 2 to the power 1 equals what? 2. So what's happening from here to here? You're dividing by 2. You're dividing by 2. So let's continue that process, and then you go 2 to the power 0. Well, that means I have to divide what? 2 by what? 2 by 2. Well, 2 divided by 2 is what? 1, you see? You understand? Okay. All right. So once you get into negative numbers, what happens? 2 to the power negative 1 equals to what? If I divide this by 2, okay, what do I get? 1 over 2, right? Yeah. If I continue this process to a negative 1, I have to divide the 1 by what? By 2. So I would get 1 over 2. So 2 to the power negative 1 is 1 over 2. Okay? 2 to the power negative 2 is what? 1 over 2 squared. All right? Okay. Okay, please. Listen. Brackets are very important when we are working exponents. If you don't put brackets or put brackets, it gives you like totally different answers. So do really be careful. Negative 2 squared is actually what? Negative 2 times what? Negative 2. Because it means it's talking about this whole thing here being what? Squared. So you know what? The negative is also being squared. So negative times negative is what? Positive, you see? So negative times negative is positive. So this is actually ends up being positive 4. However, this right here, okay, is different. The base for this one is actually just 2, not negative 2. So be careful. The base is being multiplied how many times? Twice, not the negative. Okay, so this is negative and then 2 times 2, which equals to negative 4. So let's say you have a negative base. So negative base to an even exponent. Okay, the final answer should be what? Positive or negative? Positive, right? So you're going to get a positive number. However, if you have a negative base and you have an odd exponent, then this is going to be a what? A negative number. Okay. Another thing with brackets, let's say you have rational numbers in brackets. What happens in this case? You remember? What's being squared? Both. So you actually have to square both here. And so this is 2 squared divided by what? 3 squared. 3 squared. Ay, ay, ay. 3 squared. You got it? Okay. Okay, so let's graph y equals 2 to the power x. So make a table of values. I'll choose 0, 1, 2, 3, 4. And here are the values. Now, if you want to see if this is exponential or not, you shouldn't do the first differences or the second differences. That's not going to help at all. Okay? What you should try to do is you actually have to find the factors. Okay? And the way you do the factors is just, okay, 2 divided by 1. So 2 divided by 1 is what? 2. Okay? 4 divided by what? 2 is 2. 8 divided by 4 is 2. And then 16 divided by 8 is 2. Notice that they're all the same. Meaning what? From value to value is being multiplied by 2 every single time. Okay, so 1 times 2. 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. Okay, so this is exponential. All the factors are the same. Therefore, this is exponential. Okay. All right, let me just sketch a quick graph of what this might look like, okay? So here's my x-axis, here's my y-axis. When x equals 0, y equals what? 1, right? When x equals 1, y equals what? 2. Okay, so 2. When x equals 3, y equals 4. And when x equals 4, y equals, no, I missed 3, didn't I? When x equals 3, okay, we're going to have y equals 8, so double the last one. So it looks somewhat like that. So you notice this here, okay? Now, what do you think it looks like on the other side, on the negative side? It goes down. Yeah, it actually will end up going down. Let's try negative 1. Negative 1, so 2 to the power of negative 1, remember, is 1 over what? 2. So that's a half, right? So it's a half. So for negative 1 is actually a half. And then the next one is what? Half of a half. So it's a quarter. And then half of a quarter, and so on. And so it keeps going down, 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 down. Now, so technically, technically that exponential graph is not going to what? Is never going to what? Stop or what? Is never going to what? Touch the x-axis, right? Technically, it will never touch the x-axis, right? Because it will never equal to 0. Do you understand that? Okay? Alright, so that's the exponential graph. Okay, it's not a U like the parabola. It's just a one-way up or one-way down. Okay. Yeah, you could graph it in decimals. But this is called the exponential growth. Notice it's going up. So this is a growth. Okay. And then if it goes the other way, it will come this way. Whoops. Shouldn't go over the x-axis like that. Okay, so this way, and this will be a decay. It's called a decay. Okay, so this is an exponential decay.